Welcome to the Cloud Developer Certification Preparation Series, Application Scaling in IBM Bluemix Platform as a Service. After completing this unit, you should understand scaling concepts for a cloud application and steps to scale an application in IBM Bluemix Platform as a Service, including vertical scaling, horizontal scaling, how to manually scale applications in the IBM Bluemix Platform as a Service Web UI dashboard, and automatically scaling applications in IBM Bluemix Platform as a Service by using the autoscale service and scaling policy fields and options such as available metric types for runtimes, breach duration, and cooldown periods. The cloud empowers you to alter your computing resources to meet your load requirements. Capacity can be altered both manually by executing a command on a command line or through a web interface, and programmatically through predefined changes in capacity or through software that automatically adjusts capacity to meet actual demand. The ability to manually adjust capacity is a huge advantage over traditional computing, but the real power of scaling in the cloud lies in dynamic scaling. Another core tenet of cloud computing is its inherent elasticity, that is, the ability to consume more or less resources on demand, and through a pay-per-usage model. Elasticity is a critical differentiator for cloud computing that Amazon even named their IaaS offering EC2 for Elastic Compute Cloud. In this world of cloud, one of the most important features is the ability to scale. There are different ways to accomplish scaling. One is vertical scaling and the other is horizontal scaling. What's the difference between the two? Vertical scaling is often referred to as scaling up. Vertical scaling increases the resources available on the application by adding capacity directly to the individual nodes. On the other hand, horizontal scaling is often referred to as scaling out. You grow the overall application resource capacity by adding more nodes. Vertical scaling can resize your server with no change to your code. Vertical scaling means increasing the capacity of existing hardware or software by adding resources. Vertical scaling is limited by the size of the server. The following image shows an application that has been scaled vertically by adding more memory and CPUs. Horizontal scaling affords the ability to scale wider to deal with traffic. It is the ability to connect multiple hardware or software entities, such as servers, so that they work as a single logical unit. This kind of scale cannot be implemented at a moment's notice. The following image shows horizontal scaling. Identical nodes are added with a load balancer in front of the application nodes. The IBM Bluemix Web UI dashboard and command line support both vertical and horizontal scaling through increasing the amount of memory and increasing the number of instances of an application runtime. To configure the policy for the autoscale service, on the IBM Bluemix dashboard, click Add a Service to bind the autoscaling service to your application. The Restage application window is displayed. In the Restage application window, click OK to restage your application. In the Bluemix user interface, click Your Application. In the Services section of the dashboard, click the Autoscaling service icon. You can now define the autoscaling policy. See Metric Statistics and view the scaling history. For policy configuration, you can create or edit the scaling policy that contains instructions for triggering scaling activities. For Liberty or Java applications, you can define scaling rules for throughput, JVM heap, memory, and throughput. For Node.js applications, you can define scaling rules for throughput and memory, and for Ruby applications, you can define scaling rules for memory. You can also define multiple scaling rules for more than one metric type. However, the autoscaling service does not detect conflicts between scaling policies. When you define the scaling policy, you must ensure that multiple scaling rules do not conflict with one another when the application scales in or scales out on a per instance basis. IPS is for setting scaling policy. If the workload of your application grows very fast in a short time, set the breach duration to a small value to enable your application to be scaled out before the CPU memory is exceeded and the application crashes. If the metric type that you selected, either CPU memory or heap, goes up and down in a short amount of time, specify a higher value for the statistic window. To determine whether your CPU application exceeds the number or lower threshold, autoscaling considers the metric data within the time range or the value specified on the statistic window parameter and calculates the average. The higher the value specified for the window, the wider the data range it selects to calculate whether the application reaches the upper or lower threshold. After the first scaling out is complete, the second scaling out is not triggered before the cooldown time period passes. This practice provides enough time for the application status to become ready. Specify a short time period for cooldown for demo purposes and use a longer time period for production environments. You can also view metrics in the autoscaling service. Metric statistics displays the metric stat for instances of your application. You can see the average statistics and select specific instance to see its statistic. You can also view scaling history in the autoscaling service. The scaling history displays the scaling history of your application during the past week, which displays the scaling history for the past week. Past month displays the scaling history for the past month, or a custom range. You can set the time period. You can also filter the history record by selecting the appropriate scaling status or scaling in, out. Please visit the resource links for more information.